Dear students, today we are going to start the new chapter on plane. Now, what is a plane? A plane is a surface such that the line joining any 2 points on it lies completely in the surface. For example, if you take this paper, right? If you take 1 point here, 1 point here, and join these 2 points, then this line will be completely on this paper. So this is a plane. Now, equation of xy plane. What is xy plane? Xy plane is this one. And on xy plane, z coordinate is always 0. So equation of xy plane is z is equal to 0. Similarly, equation of yz plane is x is equal to 0. And equation of zx plane is y is equal to 0. Equation of a plane parallel to and at a distance a from yz plane is x is equal to a. Right? Equation of plane which is parallel to yz plane and a distance a from yz plane is x is equal to a. Similarly, equation of plane parallel to and a distance from the zx plane at a distance b from the zx plane is y is equal to b. And equation of the plane parallel to and at a distance c from the xy plane is z is equal to c. Now, what is general equation of the plane? General equation of the plane is ax plus by plus cz plus d is equal to 0. Means any equation which is this of first degree in xyz will represent a plane. You can note down one thing, that what do ABC represent? ABC represent direction ratios of the normal to the plane. Remember, there is no meaning of saying that direction ratios of the plane. No. Direction ratios of the normal to the plane. For example, if we have this plane, 2x plus 3y plus 4z plus 5 is equal to 0. Then what do these 2, 3, 4 represent? 2, 3, 4 represent direction ratios of the normal to the plane. Okay, we'll be using this very often, so kindly remember this. Next formula is known as one-point form, which is equation of a plane passing through a point x1, y1, z1 is given by a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. This is equation of the plane which passes through the point x1, y1, z1. Then we have intercept form of the plane. If a plane makes intercepts of the lengths a, b and c on x-axis, y-axis and z-axis, then equation of the plane is given by x upon a plus y upon b plus z upon c is equal to 1. This is of the same form you have studied, intercept form of a line x upon a plus y upon b is equal to 1. In 3 dimensions we have a plane, and equation of the plane is this one, x upon a plus y upon b plus z upon c is equal to 1. Then we have normal form of the plane, Lx plus my plus nz is equal to p, where L, M, N are direction cosines of the normal to the plane and P is the length of perpendicular drawn from the origin to the plane. From origin, if you draw perpendicular on this plane and suppose length of that perpendicular is P, then equation of the plane is Lx plus My plus Nz is equal to P, where L, M, N denote direction cosines, not direction ratio, direction cosines of the normal to the plane. Next formula is equation of a plane passing through 3 points x1, y1, z1, x2, y2, z2 and x3, y3, z3. So this plane is given by determinant of x, y, z1, x1, y1, z11, x2, y2, z21, x3, y3, z31 is equal to 0. Corollary of this is the 4 points xr, yr, zr where r varies from 1 to 4 are coplanar if and only if determinant of x1, y1, z11, x2, y2, z21, x3, y3, z31, x4, y4, z41 is equal to 0. This is just a note. If ax plus by plus cz plus d is equal to 0 and x cos alpha plus y cos beta plus z cos gamma is equal to p represent the same plane, then we have cos alpha upon a is equal to cos beta upon b is equal to cos gamma upon c is equal to minus p upon d. Minus p upon d is a constant. That means direction cosines normal to the plane ax plus by plus cz plus d is equal to 0 are proportional to a, b and c, which are direction ratios. Okay, now let's take few examples. Find the equation to the plane which makes the equal intercepts on the axis and passes through the point 1, 2, 3. Now because the plane makes equal intercepts, so we shall take an intercept from the plane x upon a plus y upon b plus z upon c is equal to 1. Now because in this case intercepts are equal, so a is equal to b is equal to c. So therefore equation of the plane is x upon a plus y upon a plus z upon a is equal to 1. That means x plus y plus z is equal to a. Now because plane passes to the point 1, 2, 3, so therefore 1, 2, 3 will satisfy this equation. So we have 1 plus 2 plus 3 is equal to a. That means a is equal to 6. So therefore equation of the plane is x plus y plus z is equal to 6. Let's take next example. Find the intercepts made on the coordinate axis by the plane x plus 2y minus 2z is equal to 9. This is the first part. Then in the second part we have to find out direction cosines, the normal to the plane. So let's change this equation the plane in the intercept form. So equation of the plane will be x upon 9 plus y upon 9 by 2 plus z upon minus 9 by 2 is equal to 1. So if we compare with the intercept form, we have a is equal to 9, b is equal to 9 upon 2 and c is equal to minus 9 upon 2. So these are the intercepts made by this plane on the coordinate axis. Now we have to find out direction cosines. So if we compare given equation the plane with general form of the plane ax plus by plus cz plus d is equal to 0. So we have a is equal to 1, b is equal to 2 and c is equal to minus 2. And we know that L is equal to a upon under root a square plus b square plus c square. So put the values of a, b, c. We'll get L is equal to 1 upon 3. Similarly, m is equal to 2 upon 3 and n is equal to minus 2 upon 3. So these are the direction cosines of the normal to the plane. Find the equation of a plane parallel to the plane x minus 2y plus z plus 6 is equal to 0 and passing through the point 1, 1, 1. Now if two planes are parallel, their direction ratios are proportional. Right? So any plane parallel to the given plane is x minus 2z 2y plus z plus k is equal to 0. Only difference is in the constant and we have to find out value of this constant. And now because this plane passes to the point 1, 1, 1, so put 1, 1, 1 here and we get k is equal to 0. So therefore equation of the plane is x minus 2y plus z is equal to 0. Let's take next example. If P is the point 7, 8, 9, find the equation to the plane through P. So plane passes to the point 7, 8, 9. 7, 8, 9 lies on the plane at right angles to OP, where O is the origin. So plane passes to the point 7, 8, 9 and is perpendicular to OP. That means OP is the normal to this plane. Okay. Let's find out equation of the plane passing to the point 7, 8, 9 using one point form. So plane passing through P is A into x minus 7 plus B into y minus 8 plus c into z minus 9 is equal to 0. So we have to find the values of a, b and c. Now what are direction ratios of OP? Using the formula x2 minus x1, y2 minus y1, z2 minus z1. So we get direction ratios of OP as 7 minus 0, 8 minus 0, 9 minus 0. That is 7, 8, 9. So these are the direction ratios of OP. And ABC also represent direction ratios of the normal. So these two are proportional. So you can put here 7 into x minus 7 plus 8 into y minus 8 plus 9 into z minus 9 is equal to 0. That means 7x plus 8y plus 9z minus 194 is equal to 0. Let's take one more example. Show the 4 points 0, minus 1, 0, 2, 1, minus 1, 1, 1, 1 and 3, 3, 0 are coplanar. So we have to show that these 4 points are coplanar. So what is the method to prove this? We'll find out plane which passes through 3 points, and then we shall show that the 4th point also satisfies that equation of the plane. Okay. Now let's find out equation of the plane passing through 0, minus 1, 0. Use 1 point form. So we have a into x minus 0 plus b into y plus 1 plus c into z minus 0 is equal to 0. This is the equation of plane passing to this point. Now because this plane also passes to these 2 points, so put x, y, z as 2, 1, minus 1 and x, y, z as 1, 1, 1. So we get these two equations. 2a plus 2b minus c is equal to 0. A plus 2b plus c is equal to 0. Now from these three equations 1, 2 and 3 we eliminate a, b, c. So eliminating a, b, c from 1, 2 and 3, we write down the coefficient. So what is along with a? X. So we have x, then y plus 1, z, and coefficients of a, b, c are 2, 2, minus 1, and coefficients of a, b, c are 1, 2, 1 is equal to 0. Now you expand this 3 by 3 determinant and we will get it as 4x minus 3y plus 2z minus 3 is equal to 0. So this is the plane which passes through these 3 points, and now we should show that 3, 3, 0 also satisfies this equation. So put x is equal to 3, y is equal to 3 and z is equal to 0. So we get 12 minus 9 plus 0 minus 3, which is equal to 0. That means 3, 3, 0 satisfies this equation. So that means 4th point also lies on the plane. So therefore given points are coplanar. Okay, thank you.